Hi, I'm Jason Brozen, Leaf Safety and Technical Trainer here at Tyndale. Welcome back for another episode of the 70E Made Easy. This episode is going to be the second half of the Electrically Safe Work Condition, the ESWC. I want to remind you of a few points from the last video in case you didn't get to see it. The ESWC is 8 steps. I covered the first 4 steps in the previous video. This is not an instructional or a how-to video. I'm going to tell you what the 70E says, but you're going to have to get into your own electrical safety program for your procedures to de-energize equipment at your specific job site location. I also want to make clear that creating an ESWC is energized work. You need to understand your policies and procedures for working energized at your location. Please note that the checklist that we're going over here in the 70E is a minimum standard. There might be more processes required to ensure safety in your specific situation. Okay, now that those disclaimers are done, on to step 5, which instructs us to block or relieve stored non-electrical energy in the devices to the extent that the circuit parts cannot be unintentionally energized by such devices. There are several non-electrical energy sources. Some typical examples might be your pneumatics, your hydraulics, there's a whole bunch, but mainly includes a breaker that has been charged but the close or on button has not been pressed yet. This would be mechanical energy that could energize the breaker and must be blocked or released. Pressure switches that can close after a certain amount of air leaks out would also be an example that shares the mechanical as well as the electrical side of things. Step 6 instructs us to apply a lockout-tagout device in accordance with a documented and established procedure. I really feel the need to highlight that phrase, documented and established procedure. This means that this is on you to build and implement a lockout-tagout program at your facility. And like I said in a previous video, it's pretty difficult, if not impossible, for someone to teach you lockout-tagout in a instructional video or even online, because you really need to visit your site and help you create that program based on the equipment you have and the steps needed. Step 7 is a little bit more detailed and addresses the need for absence of voltage. Step 7 instructs us to use an adequately rated portable test instrument to test each phase conductor or circuit part at each point of work to test for the absence of voltage. You need to test each phase conductor or circuit part, both phase to phase and phase to ground. Before and after each test, determine that the test instrument is operating satisfactorily through verification on any known voltage source. This means that you are checking A to B, B to C, A to C, A to ground, B to ground, C to ground. Any combination that could have potential, you need to check. You're also doing a live dead live test before and after you do these tests. So you're checking on a known voltage source, you're checking exactly where you're working, and then you're going back and checking that again to make sure that your meter is working properly. You can do this with a wall outlet, you can use a meter proving station, or any other power source that you feel meets the criteria of this step. But it is an important step. You're allowed to use a permanently installed absence of voltage meter at the specific work location as long as there's a few rules that are followed. Number 1, that absence of voltage detector meter is permanently mounted and installed per the manufacturer's instruction, and it tests all the terminals at the location that you are working. That's important. Number 2, it's listed and labeled for the purpose of testing for absence of voltage. I'm not going to get in the weeds. There's a lot of argument about there, what's approved and not approved. I'm going to let you work on that yourself. Rule number 3, it tests all combinations of phases to ground. And then finally, number 4, the unit self-test before and after each AOV testing to verify correct operation of the unit. So there's a lot of rules there. You can go back and review that, but it's all on the 70 as well. It's important to note that when you meet or exceed 1,000 volts, it is okay to use an approved non-contact type testing device. It's good to limit your direct contact with those higher voltage or medium voltage like that. Personal opinion, I would never recommend you use a non-contact tester on the lower voltages. I would always recommend direct contact. Now, That term adequately rated meter was in the earlier verbiage. I'm creating a bunny trail video after this one that I'm going to really focus in on what that means, because I feel that that's one of the most misunderstood concepts in the electrical industry. So stay tuned for that video, and that'll be coming up next. Finally, step 8 tells us where there's a possibility of induced voltages or stored electrical energy, you need to ground all circuit conductors and circuit parts before touching them, where it could be reasonably anticipated that the conductors or circuit parts being de-energized could contact other exposed energized conductors or circuit parts. Apply temporary protective grounding equipment in accordance with the following. If grounding clusters apply to you, you're going to need to jump into 120.6.8a for the important details of your placement, capacity, impedance, etc. for your specific situation. For most of the lower voltage guys, the 120 to 480, you're not going to be using grounding clusters. This is going to apply when you get up to those higher voltages. Basically, to sum it up, step 8 is telling you to ground out the system for protection from induced voltages, lightning, etc. And technically, this is handled, like I said, with a grounding cluster type deal. Thanks again for tuning in, and I'm going to see you next time for that bunny trail video when I explain what adequately rated means on a meter. Make sure you stay safe out there.